Internal standards is a way of internally standardizing your analysis. After watching this video, you should be able to compare and contrast the utility of an internal standard versus external calibration methods that have been previously discussed, calculate the concentration and associated error of an unknown using an internal standard, and list the principles governing the use of an internal standards and provide at least one common example. This is the addition of a compound similar to the analyte, but actually not the analyte that's added to your matrix or your sample. And it can help account for small variations in something like flow rate, elution time, detector response, and some losses due. There are three keys to choosing an internal standard. One is finding a suitable internal standard. It has to be similar enough to the compound of interest but cannot analytically overlap. You also have to way of reproducibly introducing the internal standard. And third, the internal standard must not be present in the sample at any concentration. We haven't talked at all about analytical separations yet, but let me just give you sort of a brief rundown of some things that are of a general separation. So you have eluent coming into a column, and then you add a little pulse of analyte with or without an internal standard, but for this case an internal standard. And then so this solution goes into a column, and the different compounds in the column, or the different compounds in the solution, react with different strengths with the column and with the stationary phase of the column. And so you actually have separation of different compounds as a result of how long it takes for it to get through the column because of the strength of the varying strength of interaction, or varying size, or whatever. And then as it comes out, it's detected by the detector. So then what you end up with is a chromatogram where you're looking at different elution times. So this is increasing time here, and then the detector intensity. So what the detector is detecting. And so basically you're looking at area under the curve to determine concentration. And so if you have an internal standard, it can help you sort of standardize for different runs. This is pretty important for chromatography particularly. So the way that it's done is you have a response factor where you have the area of analyte signal, so area under the curve for the analyte peak, over analyte concentration equals F, which is the difference between the detector response to the analyte and the standard, times the area of the standard signal over the standard concentration. Now it's your turn to try. Test yourself with this problem to be sure that you can do an internal standard problem.